In this play pause it video for this practice for week 9, you're going to have a couple questions towards the middle where you'll be able to enter in answers, mostly because of the nature of those questions. But a lot of the questions in this one's going to deal with graphing. So you'll be given a reflective pause to allow you the chance to graph the inequality yourself, and then once you've tried it yourself, and please make sure you do try it yourself. After you've done that, then continue the video to see how it's done correctly so you can compare your answer with what is shown in this video. So let's move on to the first question. So you're asked to graph this inequality. Y is greater than or equal to 3x minus 4. So pause a moment to graph this and then compare your answers to mine once you continue this video. Well, this one's already in slope-intercept form. So the only thing that's different is that, of course, instead of an equal to sign here, I have this greater than or equal to sign here. So what I could do temporarily is more or less ignore it and go through the usual procedure of how I would graph a line in slope-intercept form. And what I would tend to do is I would start with this minus 4 for the y-intercept, and I would plot it right here. And then I would use the slope of 3, which means 3 over 1, which means up 3, right 1, or I could do negative 3, negative 1, because that would still give me a positive slope. And I would find other points that would help me draw the line. So I would go up 3, right 1, up 3, right 1, up 3, right 1. And I would plot these points. And I could follow the same pattern this way as well. And so I have, I can see like the gist of my line at this point. Now I had to make a decision. This line represents a border, between two regions. One region is going to have ordered pairs that work for this inequality. There's going to be a region that has ordered pairs that don't work. I have to know if this border, this line, is going to be included. And of course, I have the equal to sign here, which means it is included. So this is going to be a solid line. If it had been just greater than, I would draw it as a dashed line. Now, the Khan Academy videos go through a much more rigorous process of identifying whether to shade above or below or what part to shade. But generally, the way it works, if you want more of a shortcut, is if once you have it in slope-intercept form, and that's the operative word, it has to be in slope-intercept form. If you have a line written in any other format, you really should get it written in slope-intercept form first, because sometimes converting it would cause this inequality symbol to sometimes get changed around a bit. So once it's in slope-intercept form, if you have a greater than or equal to, you're going to shade above the line. So it's just like imagine being on the line and you're saying, okay, above, it's going to move upward. So, I would shade this. If it's a less than or equal to, I would shade below. So I'd be at the line, so okay, below would be going downward. And so what I see here, the greater or equal to, I mean, it's okay, I'm going to start the line and upward. So above the line would be, in this region over here. And so that's why that region gets shaded. Those are the decisions you make for these. So let's try another one and see what you come up with, and then we'll go over it. Again, I'm going to kind of ignore the less than symbol for the time being and just go through the process of graphing this line, which is written again in slope-intercept form. So y equals 2/3 x plus 1. I'm going to start with the plus 1 as the y-intercept and plot a point here at 1. And then the slopes is telling me up to right 3, rise of 2, run of 3. So I can go up to right 3. I can also go down 2 and left 3. And I would follow those patterns to get, a sufficient number of points to draw the line. The more points you tend to draw or are able to draw, the less you might have to use a straight edge to draw your lines. So now I have to start making some decisions, because I had to make a decision: should this line be solid or dashed, and also what region I'm going to eventually be shading. The first one I'm going to make is solid versus dashed. Now, solid again means that the border, the line itself, is going to have points that make this true. That's not going to happen here. The border is not included because I don't see an equal to sign here. So this means that I'm going to put a dashed line to kind of stand for. That's where the line would be, but it's technically not really there. It's a border, but that's not where the border is. It's the border is actually infinitely close to this line. And then as far as shading goes, well, I have a less than symbol. So if I start at the line, I want to be moving downward. So this region down here is what I want to shade. And that's the graph of this inequality. Now let's try the next one. Now this one is not written in slope-intercept form. So the first thing I want to do is get this written in slope-intercept form. I don't even want to look at this yet and make decisions about shading above or below and things like that. Because, I mean, yeah, there's ways that you could graph this. And we talked about methods of graphing lines where I use intercepts. And I could use intercepts for this, although the x-intercept won't fit very well because the x-intercept at 18 is like, beyond the reach of this graph. But if it's not written in slope-intercept form, I really can't make a decision about above or below. When using the convention I've shown, you'd have to actually test some ordered pairs to see, okay, if you pick an ordered pair, it's clearly in one region. If it works, then that's the region that works. And if not, then the other region is the one that works. So, but I'm going to convert this into slope-intercept form first because it helps me draw the line a little bit better too. So I'm going to subtract x from both sides, which gives me 3y is less than negative x plus 18. I'm going to divide both sides by 3. Now I have to make sure when I divide both sides by 3 that I'm dividing on the right-hand side both terms by 3. And it has to be done. A lot of times students forget to do that, and that's where some issues lie. And when they're given graphs like this, students will be saying, okay, the graph's not going to fit on here really nicely. Chances are, if you're given a graphing region, you should be able to graph the y-intercept, if you put it in the slope-intercept form. If you find out it's not working, then you might be overlooking it, or you may be doing something incorrect, and that's why it's not fitting on the graph. So I end up with y is less than negative 1/3 x plus 6. So again, I'm going to kind of ignore the less than temporarily and just start going through the process of graphing y equals negative 1/3 x plus 6. So I'm going to start with the y-intercept of plus 6 and plot that. I'm also now going to use the negative 1/3 slope, which I can say it's either put the negative on top, it's down 1, right 3. If I put the negative on the bottom, it's up 1, left 3. And if I follow those patterns, you can see the dots I would get. This is my linear pattern. And now I make the decision, is it dashed or is it solid? There's no equal to here, so it's definitely going to be dashed. And as far as where I'm going to shade, well, it says less than, so if I start my line, I want to shade below it, less than it. So that's the region I'm going to shade. And there is the graph of the inequality. For this inequality, give it a try, see what you come up with, and then we'll go through it. So for this inequality, again, it's not written in slope-intercept form. And this is one of the reasons why I caution you, do not use this original symbol to make a decision, because a lot of people are going to say off the get-go, I'm going to shade below the line whenever I eventually get it. And you're going to see that's not going to be the case. I'm actually going to shade above, but why? Why is that the case? Well, let's go through the process of first converting this to slope-intercept form. So I'm going to subtract 2x from both sides. I didn't show the minus 2x up here, but that's what I did. I subtracted 2x from both sides and got this. I then divide both sides by negative 5. Now, if you go back to your rules for inequalities, when you're going through the process of solving an inequality, if you need to divide or multiply both sides of an inequality by a negative, and this only happens when you multiply or divide by a negative, this inequality sign will get switched around. So the process of dividing by a negative 5 is going to cause me to have a y here. This is going to get switched around to a greater than or equal to. Negative 2 divided by negative 5 is a positive 2/5. Positive 15 divided by negative 5 gives me a minus 3. So this inequality, written in slope-intercept form, becomes y is greater than or equal to 2/5 x minus 3. And as you can see now, in this format, now it's in slope-intercept form, I have a greater than, which would indicate that once I draw my line, I'm going to shade above it. So that's why you have to be careful, because the rules of inequality, switching this guy around at times, you have to make sure, okay, only once I have it in slope-intercept form, that's when I make my decision about where I shade. But first I have to draw the line. So I'm going to start down at -3 for the y-intercept. I have a slope of 2/5, so it's up to right 5. And you can see or down to left 5, and there's my the other dots that follow along that pattern. So I'm going to draw the line. The line's going to be solid because it's equal to. And because it says greater than, I'm going to shade above the line. So this region up here is what gets shaded. Now, and that's the first component, is being able to graph these, inequalities. The second component of what you're going to need to do stuff you're going to be asked to do next week is being able to translate, word problems or situations into inequalities or systems of inequalities. So let's have the first look at that. You have Wang Hao wants to spend at most $15 on dairy products. Each liter of goat milk costs $2.40. Each liter of cow's milk costs $1.20. Write an inequality that represents the number of liters of goat milk, G, and cow's milk, C, Wang Hao can buy on his budget. So take a moment, pick which of these inequalities you're going to be given is going to represent the situation, and then we'll go through it. Okay, so to break this down a little bit, I know I'm going to let G stand for the number of liters of goat milk. I'm going to let C stand for the number of liters of cow's milk. And those are the only dairy products we're talking about here. So he's going to spend $15 on goat milk and cow's milk, and the combination should be at most $15. And that's because that's what it says, at most. Now that means $15 or less. So the amount of money he's going to spend on goat's milk plus the amount of money he's going to pay for cow's milk should be $15 or less than or equal to 15. Now I got to figure out, well, how would I come up with the amount he pays for goat's milk versus the amount he pays for cow's milk? Because I don't know these things. Well, the amount he would pay for goat's milk would be $2.40 times the amount of liters of goat milk he buys. And the same thing for the cow's milk. For each liter he buys, he would be spending $1.20. So $1.20 times C would be the amount he pays for the cow's milk. So adding those two together, those are the two things that should be less than or equal to 15, and there is your inequality. And that's why you're shown these methods about how to translate these situations, because most of the time when you're given situations that are more like applications of using these inequalities and systems, you're going to be dealing with situations that tend to give you inequalities that are of this format, whereas that's not necessarily the best way to graph it. Graphing it, you might want to have it in slope-intercept form to make it a little easier on yourself. Let's try the next one. Gulnaz plans to use less than 26 eggs while baking. She uses 5 eggs for each cake that she bakes and 3 eggs for each quiche that she bakes. Write an inequality that represents the number of cakes, C, and quiches, Q, Gulnaz can bake according to her plan. So take a moment, see if you can write out an inequality, see which one of the ones that I'm going to give you as choices seem to fit the bill, and then we'll go through it. Okay, for this one here, we know that she plans to use less than 26 eggs while baking. So we know that the number of eggs she uses for cake and the number of eggs she uses for quiche should be less than 26. So again, I have to figure out, well, how am I going to figure out the eggs she uses for cake in total? Well, it's going to be 5 eggs for each cake that she makes. And I don't know what that is, so if I take 5 times C, that's going to give me the eggs that she's going to use for cake. The eggs for quiche, likewise, is going to be 3 for each quiche, so 3 times Q is going to give me the number of eggs she's using to make her quiche. And of course, if I add those together, I want that total to be less than 26. So that is the inequality that you come up with for this. It doesn't work any different when you're dealing with systems of inequalities, because usually you're just given multiple conditions and you have to make sure you separate them correctly. Now, this initially, you're going to be told how to separate them, but sometimes when you're asked to apply them, you have to kind of know what you're looking for and what's going to kind of constrain or dictate your limits to certain problems. So Take case in point. It takes 44 ink cartridges and 200 pages to print a book, and it takes 30 ink cartridges and 80 pages to print a magazine. Sarah wants to print books and magazines with at most 300 ink cartridges and 1,200 pages. Let B denote the number of books she prints and M the number of magazines she prints. And you're asked to write two inequalities. Write an inequality that represents the condition based on the number of ink cartridges, and write an inequality that represents the condition based on the number of pages. So take a moment, answer these two questions that you're going to be given, and then we'll go through this. Okay, so the two things that are limiting, how many things she's going to be able to print all together. I mean, she's printing magazines, she's printing books. Okay, she only has, how many it takes to do a book, how many ink cartridges and pages for a magazine, and you know how much she has at her disposal to make use of. So if I use ink cartridges, I want to see, okay, if 300 ink cartridges is what she has at most, that means that it has to be less than or equal to that. I'm going to look at the ink cartridge information. It's 44 ink cartridges for a book, 30 ink cartridges for a magazine. So for me to figure out, well, how many ink cartridges would she be using to print books? Well, that's going to be 44 times B. How many ink cartridges is it going to take for her to do a magazine? That's going to be 30 times M. And then those two added together should be less than or equal to 300. And that's where I get this first inequality. 44B, which will be the number of ink cartridges used for the books she eventually will print, and 30M, which represents the number of magazines that she'll eventually print. Well, actually, not the number of ink cartridges she'll use for printing the magazines. Those combined totals should be less than or equal to 300 ink cartridges, because that's all she has at her disposal. The same thing for pages. For pages, it's 200 pages for a book, 80 pages for a magazine. So again, the number of pages that are devoted to books is going to be 200 times the number of books, which is B. Same thing with the magazine. It's going to be 80 times the number of magazines. Adding those together, I should have less than or equal to 1,200 pages. And that's all we want you to do with these right now is just write the inequalities. Eventually, we will take these inequalities and graph them to come up with possible ideas for answers. But there'll be some more that comes along with it. So let's take a look at one more question like this. It takes 31 employees and $7,500 to build a car, and it takes 19 employees and $4,300 to build a motorcycle. Genji's Motors, I hope I'm saying that right, wants to spend more than $84,000 to build cars and motorbikes using at most 706 employees. Let C denote the number of cars they build, and M the number of motorbikes they build. Write an inequality that represents the condition based on the number of employees, and write an inequality that represents the condition based on the number of dollars. So take a moment to answer the questions you'll be given in this play pause it, and then we'll continue. Okay, so again, these are the two conditions that affect what we can possibly, cars we can make. We have the number of employees that I want to be at most 706. So there's 31 employees needed to make a car, 19 employees to build a motorcycle. He wants to use at most 706 employees, which means 706 or less. So, the number of employees used for cars would be 31 times C. The number of employees used for a motorcycle would be 19 times M. If I add those two together, it should be less than or equal to 706, and that's where I get this inequality from. As far as money being spent, which is kind of a strange situation they're giving you here, he wants to spend more than $84,000. Now, usually you would limit yourself and say, I'm going to spend, up to this amount. But here he says, for whatever reason that the motor company has, they want to spend more than $84,000 to make these, vehicles. So I'm going to use that $84,000, it's $7,500 to build a car, so if I want to figure out how much money was spent on making cars, I would take 7,500 times C, the number of cars. And likewise, the amount of money spent making motorcycles would be 4,300 times M. And since I want it to be more than 84,000, that's going to be greater than 84,000. So I would have 7,500 C plus 4,300 M, which is greater than 8,400. Up to this point, as you see, we're coming up with situations where you come up with systems of inequalities. And we're going to be able to obtain answers from this, but we're going to have to start being able to graph them and find what we would call a feasible region, which would be a region of a graph of a Cartesian coordinate system that ordered pairs would work with both, or if there's more than two inequalities, all three, all four, all five, whichever the case may be. Which ones would work with all those inequalities, so I would know, okay, well, here's a region of here's some possible combinations that'll work. So let's get into graphing systems of inequalities, which is really no different than graphing each inequality separately and then seeing where there's an overlap, if any. So take a moment here and first graph, this system of inequalities, and then we'll go through it so you can check your work. So first I'm going to graph y is less than 3x plus 4. And I'm not going to go through and show it all step by step. I'll just kind of show the result and then explain why that is the result. So when I graph that, again, I have y-intercept of 4. I have a slope of 3, which means up 3, right 1, up 3, right 1, so forth and so on. It's a dashed line because there's no equal to, and I should be shading below that line because of the less than. For y is greater than or equal to negative 1/2 x minus 1, I'd be graphing this. Now, again, y-intercept of negative 1, slope is negative 1, 2, so down 1, right 2, or up 1, left 2. And as you can see, it's a solid line because it does have an equal to, and because it is greater than, I'm shading above it. Now, the solution for this system of inequalities is this region right here, because this is where the two regions overlap each other. And so that region there is the solution to this system of inequalities. Let's try another one. So this one isn't too bad either because, again, everything is written in slope-intercept form, with the exception of x is less than or equal to 4, but we know that's a vertical line because x equals 4 is a vertical line. So, but here we are asked to graph three things. So I want to see where three different regions would overlap each other. So first I'm going to graph y is greater than or equal to negative 2x minus 1. So to kind of explain here, negative 1 is the intercept. It has a slope of negative 2 or negative 2 over 1. So it's either up to left 1 or down to right 1. It's a solid line because of the equal to. And because it's greater than, if I'm at the line, I'm going to shade above it, things that are above that line or moving up on the y-axis. For y is less than 3x plus 2, it would look like this. And again, a couple of things. Plus 2 is the y-intercept. It has a slope of positive 3, so that's up 3, right 1, up 3, right 1, or down 3, left 1, whichever the case may be. No equal to symbol, so it's dashed. And since there's a less than symbol, if I'm at the line, I want to go to y values that are below it. So that would put me in this region here. And you can see the overlap between these two regions. So far, this would be my feasible region. But I do have one more feasible region to consider here. X is less than or equal to 4. That's just going to be a vertical line, and everything to the left of it would be the solution to that one. And now you can see that there's a region now where all three of these overlap in this little triangle area here. So that would be the feasible region for this system of inequalities, and that would represent the solution. The borders here, this green line and this pink line, that would also include answers that would work for all three of them as well. But nothing along the blue dashed line would work. So ordered pairs within this region, these two borders, yes. This border, no. Try another one. The only thing different about this one now is that they're not written in slope-intercept form. So be cautious as you take these on so that you make sure you are graphing the correct information. Okay, so both of these are written in more of what they would call an expanded or standard form, not in slope-intercept. And if it's not written in slope-intercept, you know, the greater than and greater than or equal to's may not be telling you the information you need to know as far as what you'll be graphing. So let's take 2x minus 5 being greater than 10 first, and I'm going to slowly convert this into slope-intercept. So I'm going to subtract 2x from both sides and get negative 5y is greater than negative 2x plus 10. To get y alone, so I have this in slope-intercept, I'm going to divide both sides by negative 5. Dividing by a negative now is going to cause me to need to change this symbol around to a less than. So I'm going to have y is less than negative 2 over negative 5 would be a positive 2/5. Positive 10 over a negative 5 would be a minus 2. So this inequality becomes y is less than 2/5 x minus 2. So when I go through and plot it, I'm going to have the y-intercept at negative 2. It's a slope of 2/5, so up to right 5, up to right 5. You can see that. It is a dashed line because there's no equal to, and I'm shading below that line because of the less than symbol. So that's the first part of it. 3x plus y is greater than or equal to 4, not in slope-intercept form. So I'm going to subtract 3x from both sides. And that gives me y is greater than or equal to negative 3x plus 4. Notice I subtracted 3x. It doesn't change the symbol around. Only when I multiply or divide by a negative does that happen. So this is still y is greater than or equal to negative 3x plus 4. So I'm going to graph that. Y-intercept of 4, slope of negative 3, solid line. And since there's a greater than symbol here, I'm going to shade that y value is above it. And there you have it. And as you can see here, you can see the overlapping of the two regions right here. And so that would be the solution area, or the feasible region. It would include the border for the second line. It wouldn't include the border for the first line. So anything in this yellow region and this border here would work for both inequalities. And one last one. Try this system of inequalities, graph it, and then we'll go through it. So the first two, again, are not written in slope-intercept form. So before I start deciding where things are going to go, I mean, I could plot points. I mean, I could use intercepts to do this. But the problem is, I start using intercepts. This greater than symbol is not going to be interpreted necessarily as me shading above the line I would get. You know, same thing down here. I could probably find some intercepts, but this less than or equal to may not define where I should be shading in relationship to whatever line I draw. So this one's just a horizontal line. It's already in slope-intercept form, so this one's not too hard to deal with. Let's start with 10x minus 6y is greater than negative 30. So I'm going to subtract 10x from both sides. And then I'm going to divide both sides by negative 6. Dividing both sides by a negative is going to cause this to need to be turned around. So I'm going to end up with y is less than 5/3 x plus 5. So I'm going to have a y-intercept at 5. I'm going to have a slope that goes up 5, right 3. And I'm going to have a dashed line, which I'll be shading below it. And there you have that. 2x plus 7y is less than or equal to 14. Again, I'm going to subtract 2x from both sides. And I'm going to divide both sides by a positive 7. There's no need to turn this around because I'm dividing by a positive. So I would have y is less than or equal to negative 2/7 x plus 2. So 2 as a y-intercept, down to right 7 for a slope. So it's going to kind of go in this direction. It's going to be a solid line. I'm going to shade below that. And then y is greater than negative 7. So y equaling negative 7 is a horizontal line at negative 7. Since I'm doing greater than, I'm shading above it. And now you can see where the three regions are overlapping. They're overlapping in this region right here. If I had more space, you would see it would eventually close off into a triangle type shape. I don't really have enough of it here, but this is the feasible region for the graphing area that you have, and that would represent where the solutions are for this system of inequalities. And that is the end of this video. If you have any further questions, please make sure to reach out and ask me about them. Until next time, have a good day.